Margarine is one molecule away from being plastic? What on earth does that mean? Well, let's just think about this a moment. That's ethylene. If you take ethylene and you react it with water, you get ethanol. That's the alcohol that we drink. So I suppose one could say that ethanol is a product of ethylene and water. That, of course, is correct. And that ethylene is one molecule away from being ethanol. I mean, you could use those words. It's still totally meaningless, but at least, you could say that. Or you could look at water and say that water is one atom away from being hydrogen peroxide, because H2O2 is one oxygen away from H2O. Well, so what? That has no meaning. The fact that there's only a difference of one oxygen doesn't mean that there's only a little difference between those. There's a dramatic difference between hydrogen peroxide and water. But when it comes to saying that margarine is one molecule away from plastic, I can't even imagine where that comes from. Margarine is essentially a fat. And fats are triglycerides, as you know, with fatty acids attached to a backbone of glycerol. This has nothing to do with plastics. So it is just absolute nonsense. And there's a lot of nonsense out there. There are books that tell you that you can cure virtually any disease by just paying attention to the foods that you eat in terms of their pH, that is their acid-alkaline level. And this is a very, very seductive thing, because these books will tell you that over-acidification is the root of all of our problems. And they'll give you pseudo-scientific lingo like this: chronically over-acidic pH corrodes body tissue, slowly eating into the 60,000 miles of veins and arteries like acid eating into marble. If left unchecked, it will interrupt all cellular activities and functions, from the beating of your heart to the neural firing of your brain. Well, that fires things in my brain when I see things like that, especially when they say that overweight is actually an over-acidification problem. You cannot acidify the body. Our blood is a buffered system, pH roughly 7.3. If it varies too much from that, you will have a much bigger problem. You'll be dead. What does it mean that it's a buffered system? It means that our body can automatically neutralize excess alkali or neutralize excess acid. So what do they mean by a diet that features alkaline foods? Well, what they really mean is that these foods, if combusted in the laboratory, leave behind a residue, and that residue is alkaline. This has nothing to do with alkalizing the blood. These foods can change the pH of the urine, which is the only bodily fluid that can be affected in any significant way by the diet. But it makes for a very attractive argument that you can alkalize your body. And of course, they will take some smidgen of scientific fact to try to justify it. They'll talk about Otto Warburg, who back in the 1920s got a Nobel Prize for studying the multiplication of cancer cells in the laboratory, and noted that they multiplied more quickly in an acid environment. But that had nothing at all to do with eating any kind of food. But of course, they leave out those kind of details. And not only that, many of these companies that promote this notion of eating alkaline foods, and so-called experts who promote this, will also want to sell you various kind of devices, like this pH water device, whereby it makes alkaline water. Outrageous amounts that they charge for this. And of course, the notion is that it will cure cancer and other diseases. Nonsense. But in any case, if you want to drink alkaline water, all you have to do is take a bit of sodium bicarbonate and put it in your water. You don't have to spend thousands of dollars to get some kind of gizmo that makes for alkaline water. But the promoters make good money on this, but sometimes they do get caught. Robert O. Young, one of the biggest promoters of the alkaline diet, has recently been arrested, and he was charged 18 counts of felony, including practicing medicine without a license and grand theft. He pleaded not guilty. He's out on a $100,000 bail. It'll be very interesting to see what eventually happens. But there are many people who were taken in by this alkaline business, And generally these are desperate people, and desperate people will do desperate things. So we've talked a lot of sense in this course, but unfortunately there's a lot of nonsense out there in the world of nutrition. Of course, what we try to do is take the pieces of the jigsaw and put them together and try to separate the sense from the nonsense. And we want to leave you with some important points. First, the presence of a chemical does not equal the presence of a risk. It's a question of which chemical, what it is doing, how much of it is in there. If you saw the list of chemicals that an orange is composed of, it would be an arm length long. But just because there are a lot of components and a lot of tongue-twisting names doesn't mean that they are dangerous. So the presence of a chemical does not mean the presence of a risk. There are no safe substances, only safe ways to use substances. The dose, of course, always matters. And a high-dose trial in an animal experiment does not necessarily mean that the same chemical in lower doses will affect humans. But unfortunately, in many cases, we can't do human trials, so we do have to resort to the animal experiments. But even closely related animals sometimes behave very differently. For example, dioxin, which is very often talked about as the most toxic substance known to man. Well, actually it is if you happen to be a guinea pig. But if you're a hamster, well, you can almost frolic in this stuff because it's about 5,000 times less toxic. So yes, we do rely on animal experiments, but we have to take into account that they're not a perfect mirror for what happens in the human body. And the effect of a chemical does not depend on its ancestry. Whether a substance was made by nature in a bush or by a chemist in a lab doesn't matter. What matters is what it is, how much we know about it, what the studies actually demonstrate. Nature is not benign. Nature contains some very dangerous substances. And as you've already gleaned from this course, and as we have seen from the comments that you've given us, there are opposing views on almost everything. And that's not surprising. We live in a very complex world, and science is not easy. Nutrition is complicated, so of course there are opposing views. However, it is rare that these opposing views are equal. There will always be more experts on one side than on the other. But unfortunately, this doesn't always come across in publications for the layperson. Because a journalist will write an article on some aspect of nutrition, will interview one expert, and then as they've been taught in journalism school, you've got to have the total picture, so they'll interview an expert on the other side and write an article as if the two views were equally important. Whereas that is rarely the case. Usually one is much more scientifically based than the other. We also have to remember that no matter what we do, we can never eliminate all risk. Life is based upon risk. We knowledgeably take risks, right? I mean, people who smoke, they know they're taking a risk. People who don't put on the seatbelt, they know that they're taking a risk. You get into a car, you're taking a risk. I mean, even if you go out for a walk, you're taking some sort of risk. And science can never prove that there's no risk associated with some activity, especially when it comes to a chemical. We can do all of the studies that we're capable of doing, but we cannot prove that the chemical that's safe in those studies is not going to have an effect on someone living in the backwoods of Nepal. So it's impossible to prove that there is no risk. And when we substitute one chemical for another, we better be sure that we know that the substance that we are substituting is safer, because you don't want to go from the frying pan into the fire. You always want to make sure that you're improving things, not just to change for the sake of change. And just because you're worried about toxicity, you've got to know that you're replacing it with something that is safer. And remember that a reduction or an increase in a small risk still leaves you with a very small risk. Let me give you an example. Every time that you go out in a thunderstorm, there's a risk of getting hit by lightning. If you go out with an umbrella, you increase your risk because that umbrella acts as a lightning rod. However, that increase in risk is trivial. We're willing to take that chance because it's better to keep dry, right? So we have to realize that an increase in a tiny risk still results in a tiny risk. And no matter what, we cannot predict all the consequences of our actions. We don't know what the future will bring. We can do all of the safety studies. All we can say is that based upon the knowledge at this time, we come to such and such a conclusion. Who could have ever predicted back in the 1930s that eventually, 50 years down the road, freons, which were then being used as a replacement in fridges for ammonia and sulfur dioxide, who could have predicted that 50 years down the road they would interfere with the ozone layer? Nobody. Anecdotes are all over the place, but the plural of anecdote is not data. Just because someone has benefited from some kind of diet or eliminated gluten and say that they feel better doesn't mean that that is science. And furthermore, repeating a false notion does not make it true. But as we so often see on the web, people repeat and repeat and repeat, and you hear something so often, you just assume that it is true. The fact is that these days, almost any position can be supported by cherry-picking data, because there's so much information that is being published. But that is not what we do, and hopefully you realize that that's not what we've done in this course. We have picked all of the cherries, and what we have done is mashed them together and then tasted to see what the information tells us and where we can go. But we have to remember that science is not a collection of unalterable truths, and certainty is elusive. So we can't be dogmatic. We will change our minds about some of the things that we've talked about during this course as more information becomes available. Indeed, if you can't change your mind, are you sure that you still have one, is the classic expression. So we go by the evidence. The world of nutrition is a confusing world. Hopefully, we've straightened out some of those pathways and changed some of the modalities out there in terms of consumption. It's been a fun ride for us. If you're interested in more, well, our Office for Science and Society, can deliver the goods. We have a website, and that website has all kinds of nutritional information, and of course it's updated on virtually daily basis. We do have a Facebook, we do have a Twitter account, so you might want to make use of that. And let me also remind you that we have an app both for the iPhone or for the Android system. So just go to the iStore or the Android store and do a search, Office for Science and Society, download it, it's absolutely free, and you will find all kinds of interesting things, not only in nutrition, but in many other areas of science. And if you do like popular science, let me mention that I have written a number of books over the years, which might be interesting if you like science stories that do not trivialize science, but make it palatable and make it interesting. And most of them are available on Amazon. So with that having been said, we now come to the end of the road, at least as far as this course goes. But of course, nutrition never ends. And information will keep coming, and you'll be reading more and more. But hopefully with what we've given you here, you now have a base to use, and critical thinking is really what it's all about. You've got the data, put your mind to work, think about the stuff that you read, and above all, enjoy food. Don't worry about every morsel, and don't worry about every drop of beverage. Thanks for listening.